In this video, we're going to talk about the quadratic formula, doing some practice with simplifying radicals, finding the discriminant, and using the quadratic formula to find solutions to a quadratic. This formula in the box I just outlined is called the quadratic formula. It is used to calculate solutions to a quadratic equation. We calculate those solutions by plugging in values from the quadratic equation itself. The part underneath the radical, this expression b squared minus 4ac, this is called the discriminant. Discriminant is part of the solution. It's what tells us how many solutions there will be. More on the discriminant later. The letters within the discriminant and the greater quadratic formula, a, b, and c, come from the quadratic equation itself. We have to make sure that the quadratic is set equal to 0, and then the letters a, b, and c are the coefficients on the terms in the quadratic. A is the coefficient on the x squared term, b is the coefficient on x, and c is the constant. Again, it has to be set equal to 0 in order for us to be able to identify those letters a, b, and c. Then, once we identify them, we can plug them into the quadratic formula. I kind of already answered number 4. We use the discriminant to find how many solutions there are to a quadratic equation. We use the quadratic formula itself to find those solutions. One of the skills that we're going to need for the quadratic formula is simplifying radicals. And when you see that word simplify, I want you to think about changing the way something looks, but not changing its value. Okay, so we don't want to convert it into decimals, because if we do, then we'd be rounding and we'd have to change the value. Rather, instead, I'm going to take the number that's underneath the radical and make it as small as possible. Similar to when we simplify fractions, if I have a fraction like 3 over 6, I would want to simplify that by taking out a common factor of 3 and changing that fraction into 1/2. 1/2 and 3/6 are the same number, same value. It's just that 1/2 is more simplified. Now, in order to simplify these radicals, I'm going to try to break them down into factors. So I'm going to try to find two numbers that multiply together to get to that number underneath the radical. Okay. So for 125, there's a few different ways that I could break it up into factors. The factors that I want are factors that involve perfect squares. 25 is a perfect square, and so I'm going to break down 125 into the factors of the square root of 25 and the square root of 3. The reason why I like that is the square root of 25 ends up being a nice value, since 25 again is a perfect square. 25, once I take the square root of it, turns into a 5, no more radical. Square root of 3 is not a perfect square, so that's going to stay underneath the radical. 5 square roots of 3, square root of 125, those are the same number, same value, it's just that 5 square roots of 3 is more simplified. Taking a look at the next one, square root of 49. 49 is itself a perfect square, so I can simplify that down into a 7. 72 is not a perfect square, so again I'm going to have to look for factors of 72 that are perfect squares. And I want to look for the biggest perfect square possible. 72 breaks down into 36 times 2. Square root of 36 is 6. So my simplified expression is 6 square roots of 2. Always want to leave our answers in exact form, but as simplified as possible. No decimals, no rounding. Now we're going to practice using the quadratic formula to solve a quadratic. First thing we want to do is make sure that our equation is set up equal to 0. Since it is, we can go ahead and identify our values for a, b, and c. Again, a is always the coefficient on x squared, b is the coefficient on x, and c is the constant. Be careful of positives and negatives. Next, I like to break down the quadratic formula by first looking for the discriminant. The discriminant, again, is this part underneath the radical. So I'm going to plug in my values into this part of the formula, b squared minus 4ac. b is 2, a is also 2, and c is negative 12. This often is the part where most folks make a mistake if they are going to make one on the quadratic formula. 2 squared is 4. Now I'm going to be subtracting the product of these three numbers. So I'm going to multiply 4 times 2 times negative 12. So I know I'm going to be subtracting a negative number here. Positive times a negative will result in a negative. 4 times 2 is 8. 8 times negative 12 is a negative 96. So my discriminant is 4 minus a negative 96, which is 4 plus 96, which is 100. The fact that this discriminant is positive tells me I'm going to have two solutions to my quadratic. To find those solutions, I got to use the entirety of the quadratic formula. So I'm going to plug in the rest of the values. I'm going to take the opposite of b, negative 2, plus or minus the square root of my discriminant. Rather than re-plugging in those values, I'm just going to use my simplified final result of 100 all over 2 times a. These are my solutions. I just need to clean them up a bit. Square root of 100 I know is 10, so I'm going to change from the square root of 100 to 10. I'm going to go through 2 more examples here in this video. I'd encourage you to try them on your own and then come back and check with the video to see how you did. Before I can identify a, b, and c, I got to make sure my equation is set equal to 0, and it's not. It's set equal to negative 4, so I'm going to make it a 0 by adding 4 to both sides. I get x squared minus 6x plus 4 is equal to 0. Now I can identify a, b, and c. A is going to be 1 since the coefficient is 1x squared. B is negative 6, and c is a positive 4. Just like last time, I'm first going to calculate my discriminant. B squared minus 4ac. B is negative 6. A is 1. C is 4. Negative 6 squared is 36. I'm subtracting 4 times 1 times 4, which gives me 16, which means my discriminant is a positive 20. Again, a positive discriminant means we should get 2 solutions. To find those solutions, we're going to use the full quadratic formula. Setting up x is equal to the opposite of b, turns that into a positive 6, plus or minus the square root of the discriminant, 20, all over 2 times a. A little bit different this time is that our discriminant is not a perfect square. So I need to simplify that. Square root of 20 can break down into the square root of 4 times the square root of 5. I like that because 4 is a perfect square. So I'm going to replace square root of 20 with 2 square roots of 5, meaning my solution is 6 plus or minus 2 square roots of 5, all over 2. Okay, we want to split this up into 2 solutions, but before I do that, I'm going to see if there's any way I can simplify it further. I can't add or subtract in my numerator since one of them is a radical and the other is not. However, I can factor out a GCF. In my numerator, my GCF is 2. When I factor out that 2, I get 3 plus or minus the square root of 5. Think of it like backwards distributing. By factoring out the 2, I see that 2 divided by 2 is going to simplify down to 1. 2 divided by 2, they're going to cancel each other out, simplifying out to 1. I'm left with 3 plus or minus the square root of 5. And again, this represents my solution. 2 of them, actually. To find each solution, I'm going to break that apart. My denominator here is over 1. You can write it as over 1 or just leave it as the numerator. It's implied that it's over 1. One of my solutions is going to add 3 plus the square root of 5. The other solution is going to subtract 3 minus the square root of 5. Alright, last one for this video. Checking my equation. It is set equal to 0, so I'm good to start identifying A, B, and C. I come up with 1, -4, and 4 for A, B, and C respectively. I'm going to check out my discriminant. B squared minus 4AC. B is -4. The entirety of -4 is going to get squared. Minus 4 times A times C. 4 squared, -4 squared, is 16. Minus 4 times 4, which is also 16. So my discriminant is 0. What this means is I'm going to have one solution. Let's see what happens when I plug it into the full quadratic formula. I get x is equal to the opposite of b, +4, plus or minus the square root of my discriminant, which is 0, all over 2 times a. The square root of 0 is 0, so my solution is 4 plus or minus 0 all over 2. It looks like there's 2 solutions because I still have that plus or minus, but if I break that up, x is equal to 4 plus 0 over 2, and x is equal to 4 minus 0 over 2, I'm going to get the same answer. It's repeated. 4 plus 0 is 4. 4 over 2 is 2, so my first solution is 2. Similarly, 4 minus 0 is 4 over 2. Leaves me with a repeated solution of 2. So, same value means there's only one solution. And that's because adding or subtracting 0 gives you the same value in the numerator.